Okay, so we are starting the next unit, the next little chapter, which is chapter 3.5, solving exponential equations. So we're going to use what we've learned so far to solve equations that look pretty inconvenient, but we will figure out a way using rules of logarithms or exponentials to solve them. And there isn't really any new content here. There's just problem solving tactics. And the most important one to remember is if b to the x equals b to the n, if the bases are the same, then the exponents have to be the same. And likewise, log to the base b of x equals log to the base b of n. If the bases are the same, then these things got to be the same. Okay? When they're in the same form, they got to be the same. So this is going to be our strategy. Can we get something to look like this, or can we get something to look like this where the bases are the same so that we can do this to solve the problem? Okay? That's our strategy here. So, first one. 20 times 1/2 to the x over 3 equals 5. Let's solve for x. That sounds like fun. And you're thinking, holy crap, Mark, really? I mean, how do you do this? I mean, really. So when I get a problem like this and I don't know how to solve for x, I got to do something. And I know one thing I can do is I can divide by 20, right? And I'll get 1/2 to the x over 3. 5 over 20 is 1/4. And now, aha, I want to get a base of 1/2. Can I write 1/4 as a base of 1/2 to some exponent? And you know what the answer is? The answer is yes, Mark, you can do that. So I could write this as 1/2 squared, right? 1/2 times 1/2 is 1/4. And oh, look, the bases are equal. If the bases are equal, what's true about the exponents? They got to be equal too. So the answer for x is 6 because we took it and I got rid of this coefficient so I could get 1/2 to a power equals 1/2 to a power, and I was able to write this as 1/2 squared. And ta-da, we got an answer. Let's look at another one. Log of x squared equals 2. How are we going to do that? In fact, there's 2 ways to do this. But we're staring at this and you're thinking, I don't know how to do this. So what do we do first? We do something. And the something we're going to do is, in the first way, I'm going to move the 2 out here. 2 log x equals 2. Okay, what else can you do? I can divide by 2. Log x equals 1. Okay. Now what do you do? If you go back and look at the rules for logs, you can figure out what this is. Or I know the base is 10. Let me write this using the Cheverton secret sauce. Base, exponent, answer. Oh, look at that, x equals 10. Okay. No, I guess that's the only way. There weren't 2 ways. Oh, I guess we could have taken this. Here's the other way. I could have taken this thing and used the Cheverton sauce right away. Base, exponent, answer. And if the exponents are the same, what's true about the bases? Yeah, they got to be the same as well. So that's kind of the 2 ways to do it. Remember, don't just sit and stare at something. Go away, Photoshop. Don't just sit and stare at something and do nothing, because doing nothing is not going to help. Come on. New book, please. Okay, these are my favorites. I love these kind. ln of 3x minus 2 plus ln of x minus 1 equals 2 ln x. And I'm sure you're thinking again, come on, Mark, how are we supposed to do that? Well, you know a bunch of stuff you can do with this. First of all, what do you do when you're adding exponents? This is the quotient rule. I can write this as ln of 3x minus 2 times x minus 1, right? That's all inside the natural log function. Equals, and what do I do over here? I'll write this as ln of x squared. Oh, look, the bases are the same. If the bases are the same, then the stuff inside the logarithms have to be the same. 3x minus 2 times x minus 1 has to be equal to x squared. So now it becomes an algebra problem. We're going to FOIL. 3x squared, first 2, outside 2, inside 2, last 2. Oops, plus 2 equals x squared. I'm going to subtract x squared from both sides. So I'll get a 2x squared. Minus 3 minus 2 is minus 5x plus 2 equals 0. Okay, we can do the quadratic equation. I don't like it because there's lots of chances for negative sign errors. We can complete the square. I don't enjoy completing the square when there's a 2 here, so let's factor. So I want to get a 2. And what are the factors of 2? Well, 1 and 2, or 2 and 1, right? And, oops, I'm sorry. 1 and 2, or minus 1 and minus 2. And I have a coefficient out here. And so when I do my multiplication, just like here, the 3x got multiplied into the 1. That 3 is going to get multiplied into something. And likewise here, I'm going to have a 2x and an x. And that 2x is going to multiply into something. I don't know which one it is. So we got to play around. So if I put it here, I'll get 2 times 1 is 2, plus 2 is 4. That's not minus 5. It's not like that. So I'll put the 2 here. 2 times 2 is 4, plus 1 is 5, but it's positive. No, that's no good. Neither of those work. So let's try this one. 2 times minus 2 is minus 4, plus a minus 1 is minus 5. Ding, 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 ding. I want the 2 to multiply against a minus 2. So I want the minus 2 over here. So I'll get 2 times minus 2, and I'll get a minus 1 here. Let's check it. First 2 is 2x squared. And then 2x times minus 2, oops, minus 4x, outside 2, inside 2, last 2. So that's 2x squared minus 5x plus 2. Yeah, that's what we got. Okay, it worked. Yay. Okay, so now let's go ahead and finish solving this. So if this equals 0, oops, I erased it. That wasn't very smart. Okay, 2x minus 1, x minus 2 equals 0. So for this to be true, either 2x minus 1 is equal to 0, or x minus 2 equals 0, right? Either this thing is 0, that factor, or this factor is 0. That's the only way you can wipe out this whole thing and set it equal to 0, make it be equal to 0. So for this one, I'm going to add 1 to both sides. 2x equals 1, x equals 1/2. For this one, I'll add 2 to both sides. That's a 2. And I'll get x equals 2. So here's our two solutions. Okay? And so there you go. Now, one of the rules with logarithms is you can't take a logarithm of a negative number. Let's see what happens if we do that, just for fun. Natural log of minus 2. Error, error, error. Let me try it again because I didn't do a natural log of -2 close paren. Still error, 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 because the natural log function is not defined for a negative number. So when I have these two numbers, I got to go back and make sure I'm not going to get a negative. When I put a 2 in here, 2 times 3 is 6, minus 2 is 4, that's okay. I put a 2 here, 2 minus 1, 2 minus 1 is 1. Okay, that's okay. Now let's see, a minus 1/2. So this is 3 times a 1/2. So that'd be 1.5. 1.5 minus 2. That's going to give us a negative number. So this one is an extraneous root. We can't use that one as a solution. Okay. Also, if you put 1/2 here, 1/2 minus 1, you're going to get a negative number also. So the only solution is x equals 2. Does that make sense? It's really important when you get two solutions. For natural logs, you got to look for natural log of a negative number, and it's the same for common log negative number, and it's the same for log of any base. You can't take the log of a negative number. The function does not exist when the argument inside here is negative. It doesn't work. So you just got to watch out for that. Okay. Next one. 3 times 5 to the minus x over 4 equals 15. I don't know. This seems impossible. We should just quit, go work on a farm somewhere. Maybe, I don't know, go to Costa Rica and pick bananas. Oh, wait, we can do something. We can divide by 3, right? So we'd get 5 to the minus x over 4 equals, what's 15 over 3? 5, and in fact, it's 5 to the first power. If the bases are equal, what's true about the exponents? They gotta be equal. Oops. X over 4 equals 1. Multiply by 4, minus x equals 4, x equals minus 4. Okay? Yay. And notice there's no restrictions here. I can have a negative in the exponent or a positive in the exponent. Nobody cares. I can't divide by 0 in the exponent. I can never divide by 0. But I don't have to worry about a negative when I'm using exponents. Okay. Log base 2 of x equals 5. How are we going to do that? Well, we could use the secret sauce and base exponent answer. So this is 2 times 2 times 2 times 2 times 2, 2, 4, 8, 16, 32. X equals 32. Ta-da! Okay, 32 times 1/4, that's a 4, believe it or not, to the x over 3 equals 2. Okay, what do we do here? Well, we're going to have to get this somehow. We have bases of 1/4 or maybe 1/2 or maybe 2. I don't know how we're going to do it. But the first thing we're going to do is divide by 32. And this is going to be 1/4 to the x over 3. 2 over 32 is 1 over 16. 1 over 16 happens to be 1/4 squared, because 4 squared is 16. So 1/4 to the x over 3 equals 1/4 to the second. X over 3 equals 2. Multiply by 3, x equals 6. So I'm hoping you're seeing the patterns while I'm doing these, because these are the kind of strategies you're going to do. Get the bases and the logs equal, get to the bases and the exponents equal. Okay, ln of x squared equals 4. What's that? What do we do first? We're going to, move the 2. So 2 ln of x equals 4. What do we do next? Divide by 2. ln of x equals 2. What do we do next? Right, put a base down here and let's use the secret sauce. Base, exponent, answer. So let's do e squared. Go find e on your calculator. Where is it on mine? I'm using a TI something or other. What is this? A TI 84, 84 plus. Wow. And so e, where are you? E is, there it is. I have e to the x. It's above the natural log button. So I'm going to do e squared. So I'm going to hit, oops, I'm going to turn it on, hit second natural log, so e to the x, and I'm going to put in a 2. And I'm going to hit enter. And I get 7.389. So there we go. Okay, know your calculator. Oh, my God, I like how it disappears when it's black. There we go. Oh, see, if it's in front of me, the background function of zoom doesn't get rid of it. But as soon as I go over here, it starts to disappear because it's comparing the contrast and the focal depth with what's behind me. But as soon as I give it some color, if it's way out here, it disappears. But as it gets in here, there we go. There it is. I've been playing around with how this background thing works. It's a great algorithm they use. Not the best, but since it's free, it's worth it. Okay, so that's all the example problems I have. I will do some more during office hours. So if you need help, you should come. And if you want to see more problems, please show up and we can do more. And you want to be really good at these because you're going to get problems on a test or a quiz about solving, and you're going to need to know which strategy to use. So please come ask for help. I'm begging you to come ask for help because nobody comes for help. And then people have trouble on the test, and there's going to be people who aren't going to pass because they never came for help. So please come for help. Okay? End of lecture. Bye.